Hi friends, in this video we are going to study about Wein bridge and we are going to analyze the balance equation for Wein bridge. Wein bridge is used to measure the frequency. It is also used as a harmonic distortion analyzer. It finds its application in audio and high frequency oscillators as frequency determining elements. So here you can see the Wein bridge has a series RC combination in the first arm and a parallel RC combination in the adjoining arm. So as always, let us find the impedance values of each arm. The impedance value of the first arm Z1 is equal to there is a resistor R1 plus 1 by J omega C1. That is the impedance of the capacitor, and we know that to make the calculation simpler, we will always try to take the J term to the numerator. So this equation can be rewrite like R1 minus J by omega C1. So we will get this by multiplying with J in the numerator and denominator. Now let us find out the admittance of arm 3. Here we are going to find out admittance Y3 because we have discussed in Maxwell bridge that if there is a parallel combination of resistor and capacitor, to make the calculation simpler, we will always go for admittance instead of impedance. So we can write the admittance as 1 by R3 plus J omega C3, and we can see that Z2 is equal to R2 and Z4 is equal to R4. So because only resistors are there in this arm. Now let us write the bridge balance equation. We can get like R1 minus J omega C1 into R4 is equal to R2 by 1 by R3 plus J omega C3. We know that because since we are considering the admittance, we have to write like this. So from this equation we can write an equation for R2 which is equal to R1 minus J omega C1 into 1 by R3 plus J omega C3 into R4. So if you are expanding the terms, we can write like R1 R4 by R3 plus J omega C3 R1 R4 minus J into R4 divided by omega C1 R3 plus R4 C3 divided by C1. So this is the expansion of the previous equation, and now if we are equating the real terms, we can get R2 is equal to R1 R4 by R3 plus R4 C3 by C1. So you can see that R4 is common in both the equations. So we can take R4 outside. We will get like R1 by R3 plus C3 by C1. So ultimately we are getting an expression like R2 by R4 is equal to R1 by R3 plus C3 by C1. So this is the equation or bridge balance equation when we are solving the real terms. Now let us equate the imaginary terms. We can get omega C3 R1 R4 is equal to R4 divided by omega C1 R3, which indicates omega square is equal to R4 divided by C1 C3 R1 R3 R4. Since we have R4 in the numerator and denominator, we can cancel it. So we will get an equation omega square is equal to 1 by C1 C3 R1 R3. And we know that the angular frequency, this can be modified as omega is equal to 1 by root of C1 C3 R1 R3. So we all know that the angular frequency omega is equal to 2 pi f, so which is equal to 1 by root of C1 C3 R1 R3, and from that we can get the value of frequency, that is 1 by 2 pi into root of C1 C3 R1 R3. So this is the very important equation of Wein bridge. So this is the value of frequency from the elements in the bridge. So we have the bridge balance equation. We have two expressions. one expression determines the required resistance ratio, that is R2 by R4, and another expression determining the frequency value. Let us write R2 by R3 is equal to R1 by R3 plus C1 by C3. So this is the first condition, we have already seen that, and this resistance ratio and the frequency value need to be satisfied. Then we can say that the bridge is balanced. So if the bridge is balancing, if the bridge is satisfying this resistance ratio and this and it is excited with this frequency, we can say that the bridge is in balance. And in most cases, in practical circuits, we will consider R1 is equal to R3 and C1 is equal to C3. And from that we can see that the equation will be reduced to R2 by R4 is equal to 2 and F is equal to 1 by 2 pi RC. So which is a general expression for the frequency of a Wein bridge. So this is the general expression for frequency of a Wein bridge. So in practical bridges, the capacitors C1 and C3 are fixed capacitors and resistors R1 and R3 are variable resistors. So they can be controlled using a common shaft. Because of the frequency sensitivity, the Wein bridge may be difficult to balance unless the waveform of the applied voltage is purely sinusoidal. So that is the main disadvantage of Wein bridge. Thank you.